Hi folks, Mr. Long here. We've got a screencast on problem B in the Tables and Graphs Analysis Review package. So this is another instructional problem, and we're going to be doing more work with tables, or the focus is going to be tables, certainly in the first part of this. And so let's start going through it. So in this question you're being given a table. There's also a graph, but that'll come later. And the function that we're talking about is p of x. We also get values of the derivative of p of x, which is p prime, and the second derivative of p double prime of x. And so in our first question, by the way, it says it's twice differentiable, right? And remember, that's an open interval there, okay, an open interval. So here's the first question. Limit as m approaches 0, p at m plus 12 minus p at 12. Well, what does that look like? Okay, what does that look like? That looks like the limit as h approaches 0 of p at h plus 12. So h plus x in this case, x plus h, doesn't matter, minus p at 12. That looks like, and then this would just be h, right, if we were doing it with h instead of p, or m rather. So look at that. It looks like the difference quotient, right? So it looks like it rise here and run here. So instead of x, we seem to be using the number 12. Well, that would mean x equals 12. And if it is a limit as h approaches 0, we're turning a secant into a tangent. What is this question asking for? It's asking for the derivative of p of x when x equals 12. Okay, that's what we're asking for. It's just p prime at 12. P prime at 12, there's the row for p prime, and I go all the way out, there's 12, so I got to look where, look where they meet, and I can go across the p prime row. Yeah, the p prime row is right there, and go up, and it's at x equals 12. And it's negative 2 is the answer. Okay, negative 2 is where p prime and x equals 12 intersect. Okay, next one. We need to get the integral from 10 to 13 for p double prime of x. So let's back this one up. What would the integral of p prime mean? Well, remember that this was in the opening video. Any integral determines how much the y value changes by in the original function. But in this case, we're going from p double prime. If we integrate p double prime, we get p prime, right? Just like if we integrate p prime, we're working towards information about p. So what this really is asking is, how much does the value of p prime change by from x equals 10 to x equals 13? Let's take a look and see if we can get that. So yeah, this would mean p prime at 13 minus p prime at 10. How much does the y value on p prime change by from 10 to 13? Well, now I can use my table. At 10, p prime is negative 0.5. At 13, p prime is worth 1.5. So I can just do 1.5 minus negative 0.5 and I get 2. Okay, that's what it means. So the area under the curve of p double prime is how much p prime is, the y value on p prime is changing by. Okay, so that idea is so important. So here's another one. Just a statement like this. Let k of x be an antiderivative of p of x, with k of 8 equal to negative 2. K of x is an antiderivative of p of x. Well, if you look at this, antiderivative with, and there's your ordered pair. So as soon as I see antiderivative and an ordered pair, probably the fundamental theorem of calculus. So f at b equals f at a plus a to b f prime of x dx. Well, look at this. I want to figure out k at 0. k at 0 is going to equal k at 8, the given value, plus the integral from 8 to 0 for p prime, or p of x. Okay, k of x is an antiderivative of p of x. That means I need to put the integral sign in front of p of x. So what is k of 8? It's given as -2. Then I have to do the integral from, I was doing the integral from 8 to 0. Again, I always want a lower number, a lesser number on the bottom, so I flip the integral, 0 to 8, and make it a negative out front. And then I look at what do I actually need to do for this? Well, I need to get the area under the curve from 0 to 8. So this time it's a graphical representation of p of x. So what's the area from here to here, from 0 to 3? I have to break it down, right? So 0 to 3 is the first one, and that's given as 3. As well, in this case, it would be -3 because it's below, right? It's below the axis, so that's -3. Then I have to do this triangle and this triangle. Now there's something here that I should have done before I even bothered to write it out. If you look at this triangle, it's 1.5 wide. This triangle is 1.5 wide. They're both 3 tall. This one is going to be negative. This one is going to be positive. Did I even need to do that one and that one? No, I didn't need to do it. I actually could have left those out, right? Because they're going to add to 0. So it's just -3 plus 2 times 3. -3 plus 2 times 3. And then, which works out to being +3. So it's -2 minus -3, which is -5. So k at 0 is -5. Again, that's a fundamental theorem question. How did I recognize that? K of x is an antiderivative, and k at 8 equals -2. So if they're telling me something's an antiderivative, it's area under the curve, and then I have a given point, and that's when I use a fundamental theorem of calculus. Now here's another one. J of x is an antiderivative of p of x. So it starts out the same way, but then it says find j prime at 3. I would still, like, let's look at this. So I'm going to go through this whole inverse notion again. So if I have the cube root of x cubed, that's x. So the cubing undoes the cube. Again, I'll go through, I think I've gone through this previously, the derivative of the integral of 2x just as 2x, right? You get the same result when you finish. So let's look at how they defined this. So they said j of x is an antiderivative of p of x. J of x is some integral of p of x. Okay, that's taking this sentence here and putting it into notation. But then it says get j prime at 3. Well, folks, what is the derivative of j of x? That's just j prime. What's the derivative of the integral? It just gets rid of the integral, and I'm left with p. It's an undoing function. So j prime of x is then p of x. Okay, j prime of x is p of x. And then all I have to do is, j prime of x is p of x. I want to get j prime at 3. J prime at 3 is just p at 3. I just go to where x equals 3 on the graph, and I read off the y value. It's -3. Okay, there's a lot of work there that I probably didn't need to do, right? I didn't need to do it. So the work that I would do, if I were writing this on an exam, that's the first thing I would do is that. I would write that. The second thing I would write is that. And then right there, that would be my last line. Okay, so 3 lines. I would state what they put here. Then it says I want j prime, so I've got to differentiate both sides. Derivative of the integral undoes the integral. Okay, so all you're left with is p of x. And then we have j prime at 3 is just p of 3, and that's the curve that I've got here is p. Okay, folks. And last one. The last one. It's been a lot of videos. Okay, this one here is, there's some challenging ones here. So this is very similar. Oh, here's the other thing that we didn't mention. This is an even function, okay? This is being defined as an even function. So notice, the graph only goes, it starts rather at x equals 0. This integral is asking for you to do an integral from -3 to 6. Negative 3 to 0 doesn't even appear on the graph. But what we know is an even integral, it's a reflection across the y-axis, right? Okay, so it looks very similar. So if I've got this area here under the curve, I'm also going to have a similar area over here under the curve, right? And again, the 2 doesn't matter, you just pull that out. So here's what I'm going to do. I'm going to break this down into an integral from negative 3 to 3, right? Because that's going to show me the equal parts, because there's going to be, this part of the integral is going to be exactly the same over here. Then I'm going to have to add on from 3 to 6, because I can break an integral down that way, right? Negative 3 to 3 plus 3 to 6. And so I've got 2p of t from negative 3 to 3, but I also have to have 2p of t from 3 to 6. Why do I have this one from negative 3 to 3? Because that's the part that's symmetrical, right? I've got this negative 3 to 0 is going to be the exact same as 0 to 3. And then I've got to have, for this plus 1 part, I've got to have negative 3 all the way 6 to 6 of 1. So remember, that's the line y equals 1. You're just getting the area under the line y equals 1 between negative 3 and 6. We already know the answer to that. What is the area under the line y equals 1 from negative 3 to 6? It's 9. It's a rectangle that's 1 by 9. So, again, from negative 3 to 3, I know that that's just 2, right? Because I've got the area here is going to be the exact same as the area over here. So I've still got 2p of t dt, but I've got 2 from 0 to 3. So this is always true for an even function. If this is negative 3 to 3, I can just make this 2 0 to 3, okay? Because it's the exact same on the left and the right. It's a mirror reflection. So 2p of t dt plus 2 of, so I just took this 2 right here, rather. So I took that 2 right there, and I moved it to right there. I moved it outside the integral. So from 3 to 6, p of t dt, and then I integrated 1 to get t from negative 3 to 6. But again, this one I would just go to the answer of 9. I wouldn't do anything else. I wouldn't do all this integration. I'm just showing all the algebraic work, but really, you know the area of a rectangle that's 9 wide and 1 tall. So then, the area from, this 2 here times by that 2 is 4. And then the area of p of t from 0 to 3 is this strip right here, which is defined in the question as negative 3. So that's that negative 3. So 4 times negative 3 is negative 12. And then we have to do the area from 3 to 6. And here's where I got a little bit smarter than I was previously. The area from 3 to 6 is this area along here, there, and this area up here. What do we know about those again? The triangles are the same size. One's negative and one's positive. It's going to add to 0. So this time I was a little smarter and I just put 0 there, okay? Because that number right there is 0. Finally, I do 6. I substitute in 6 and negative 3 and subtract. 6 minus negative 3 is 6 plus 3, which is 9. Okay, folks? So, but again, I could have done that. So what's the overall answer? The overall answer is right here, 4 times negative 3 is negative 12, plus that right there works out to be 9. Negative 12 plus 9 is negative 3. Okay, that's just, again, a question to make sure the person understands the geometry of the integral and a bit of combining symbolic work with graphical work. Okay, very last one. Okay, so this is one of those chain rule questions where you have a function inside a function. So first of all, we're defining q of x as I have to figure that out. Not zoomed there. I didn't want that to zoom. Oh well, that's okay. So let q of x equal p of 3x squared plus 1. Find q prime at 2. So let's do the inside derivative. What's the inside derivative? 6x squared. Or 6x rather. It's right there. What's the outside derivative? It's just p prime at 3x squared plus 1. So next what I need to do is I need to start simplifying. Okay, so what's x? X is 2. 6 times 2 is 12. Then I have to replace this x right here with 2. 2 squared is 4, times 3 is 12, plus 1 is 13. So I would have to use my table for p prime at 13. Right? It's not on the graph. The graph only goes to 10. The table has 11, 12, and 13. So what I need to do now is you should be looking at your table, and so all I did in this case was I simplified the 6 times 2 to 12, and then I repeated this line. Maybe not the most efficient way to do it, but so it works out to being p prime at 13. So what is p prime at 13? P prime at 13 is, if you look on the table, so folks, the good news is the audio still appears to be working, but I can't scroll down any further. Somehow it's zoomed, and this software, I don't know the command to unzoom it, but thank goodness we're almost at the end. So anyway, it's 12 multiplied by p prime of 13. If you go to your table, p prime at 13 is 1.5. And then really what we do, we have to multiply the 12 by the 1.5, and our final answer works out to be 18. Okay, so q prime at 2 is 18. So if you can fill that in on your sheet, you'll be done. So that's it, folks. You've got lots of work now to do, but you've gotten through these videos, and you're ready to go and get into that final stage of review for the AP exam. Good luck.